For decades, the undisputed kings of the long-haul sky relied on brute force. 4 massive engines, millions of pounds of aluminum. Aircraft like the Boeing 747 and the Airbus A350 conquered the globe, but they did it with a staggering thirst for fuel. In the golden age of aviation, jet fuel was cheap and airlines prioritized capacity and raw range over efficiency. By the early 2000s, the rules of the game changed overnight. Global oil prices skyrocketed. Environmental regulations began tightening. The era of brute force was dying a rapid death. Airlines were bleeding cash, and they didn't just want a slightly improved plane. They needed an economic miracle. They needed an aircraft that could fly further, carry more payload, and burn a fraction of the fuel, all while dramatically lowering the cost per available seat mile. Boeing struck first, and they struck hard. In 2004, they announced the 77 project, which would become the 787 Dreamliner. It was a revolutionary concept, an aircraft made largely of carbon fiber reinforced polymers instead of traditional aluminum. It promised a 20% reduction in fuel burn. It was a massive, bet the company gamble, and the aviation world was entirely captivated. Airbus, caught completely off guard by the sheer ambition of the Dreamliner, stumbled. Their initial response was conservative. They proposed taking their highly successful, but aging, A330 airframe, slapping on some new, more efficient engines, tweaking the aerodynamics, and calling it the A350. They assumed airlines would prefer a familiar, low-risk upgrade. They were wrong. The airlines saw right through the patch job. In a now legendary moment at the Farnborough Air Show, 2 of the industry's most powerful figures, Stephen Advar-Hazy of ILFC and Akbar Al-Baker of Qatar Airways publicly and brutally slammed the design. They told Airbus to take the plane back to the drawing board. If Airbus wanted to survive the next generation of flight, they couldn't just throw a new coat of paint on a 20-year-old design. Airbus listened to the harsh truth. In 2006, they scrapped the original idea and formally announced the A350 XWB. It wasn't just a catchy marketing slogan. It was a physical declaration of war against the 787. Airbus was betting an estimated $15 billion on a completely clean-sheet design. To beat Boeing at the efficiency game, Airbus had to master a dark art of manufacturing: composites. Over 53% of the A350 airframe is made from carbon fiber reinforced polymer, alongside advanced titanium and modern aluminum-lithium alloys. Unlike traditional aluminum, which relentlessly corrodes over time and suffers from microscopic metal fatigue with every single pressurizing cycle, carbon fiber is practically immortal under normal flight stresses. It's significantly lighter, immensely stronger. But building a composite superjet requires a continent. The manufacturing logistics of the A350 are almost as impressive as the plane itself. The wings are crafted in Broughton, Wales. Massive fuselage barrels are constructed in Hamburg, Germany, and Saint-Nazaire, France. To bring all these gigantic pieces together, Airbus utilizes a fleet of heavily modified cargo planes, the Beluga, and later the Beluga XL. Before a single passenger could step on board, the A350 had to survive one of the most brutal testing campaigns in modern aviation history.
What we need to demonstrate is that everything works well under the most extreme conditions.
5 aircraft known as MSN-1 through MSN-5 were subjected to 14 months of pure torture. They flew into the freezing, desolate extreme of Iqaluit in the Canadian Arctic to ensure the engines and hydraulics could wake up from a deep freeze of -40 degrees. They were flown to high-altitude airports in Bolivia to test engine performance in dangerously thin air. They purposely dragged the aircraft's tail along the runway during maximum angle of attack takeoff tests. They flew through intentional water troughs at high speeds to ensure engine water ingestion wouldn't cause a flameout. By the time the A350 received its joint certification, it was arguably the most proven, robust aircraft ever to enter service. For anyone managing a fleet, whether a real-world flag carrier, the A350 entirely changes the math on long-haul routes. The baseline A350 entered commercial service with Qatar Airways in January 2015, and it was an immediate, overwhelming success. But Airbus wasn't finished. Airlines wanted to pack even more seats onto high-demand trunk routes to fully replace their aging, gas-guzzling Boeing 777s. Enter the A350-1000, stretched by 23 feet, featuring a heavier, reinforced six-wheel main landing gear to handle the extra weight, and powered by the upgraded Trent XWB 97.7 engines. The -1000 became a high-capacity flagship. It is capable of hauling up to 410 passengers across the globe with untouchable economics. And then, there was the absolute frontier of human endurance, the ultra-long range. Singapore Airlines came to Airbus with a challenge. Build a plane capable of reclaiming the title of the world's longest commercial flight, a grueling, non-stop marathon route from Singapore to Newark, New Jersey. A flight pushing the 19 hours in the air. Airbus, the A350-900 ULR, by heavily modifying the fuel system to utilize existing empty space in the center wing tanks, they increased the fuel capacity by 24,000 liters without adding additional external tanks. They optimized the aerodynamics and sealed the forward cargo hold to save weight. The result was a Titan with a maximum range of 9,700 nautical miles. The globe had officially been conquered by a twin-engine jet. The final frontier for the A350 family? Global logistics. For decades, Boeing's 77 and 747 freighters held an absolute, undisputed iron grip on the cargo market. But in 2021, Airbus formally announced the A350F. With a massive, rear-loading main deck cargo door and a payload capacity of over 111 tons, the story of the Airbus A350 XWB is fundamentally a story of engineering resilience. It is what happens when a massive aerospace giant is backed into a corner, publicly humiliated by its customers, forced to abandon its safe, conservative bets, and compelled to innovate at all costs. It was an €11 billion gamble that paid off flawlessly. It forced Boeing to desperately accelerate their own developments, like 777X. It single-handedly hastened the death of the four-engine dinosaurs, putting the final nails in the coffins of the A380 and the 747, by proving once and for all that two advanced engines could do the work of four. Faster, cheaper, and infinitely cleaner. A plastic phantom that rewrote the economics of the sky, turning the impossible routes of yesterday into the daily schedule of today. A quick word from today's sponsor, Blue Cloud AI. Need a professional website for your business, portfolio, startup, or brand? Blue Cloud AI creates modern and responsive website sites that help you stand out online. Whether you're just starting out or looking to upgrade your existing site, we've got you covered. We also offer custom web development, UI and UX design, business websites, landing pages, and other digital solutions tailored to your needs. Blue Cloud AI,